In this lecture, we want to learn about a powerful feature of MCP called sampling. In sampling, MCP tool or MCP server uses the MCP client's AI or large language model to complete a task. Basically, in sampling, the flow of execution gets reversed for some time. As you can see on the picture on the right side of the screen, the MCP client sends a request to MCP tool or MCP server. At some point, the MCP tool needs large language models to process some information. Because your MCP tool itself doesn't have access to a large language model, it creates a request called sampling request and sends it back to the client. Then the client forwards that request to a large language model. In our example, we are using OpenAI. Once the large language model, in our example OpenAI, returns a response, the response is returned back to the MCP tool. MCP tool or server continues working on that information and eventually returns a final response back to the client. This process has many benefits, including resource management. The MCP client already runs in an environment that has access to AI, for example in Claude Desktop or ChatGPT Desktop. When the client has AI already, there is no point in building AI capability in your MCP servers as well. Also, as you know, different LLMs or AI models may return different responses for the same prompt. Imagine that your MCP client used OpenAI and your MCP tool used Anthropic Claude or Claude Sonnet. In this case, the same prompt would return different responses and the final response would be confusing and inconsistent. You may also get a better security using sampling because MCP tool can keep the large language model processing in a trusted client side. This model also is scalable because multiple servers can share the same client-side model. If the number of MCP clients that use your MCP server increase, you will not need to scale out your MCP server or tool because every MCP client has its own large language model or AI capability and therefore they can use their own AI and you will not have to scale out to cope for that load. This is an example where a salesperson creates a sales contract and then wants to make sure that the sales contract is legally fine and also it has to be in a specific company provided format. Has the document on a storage such as Microsoft SharePoint, grabs a sharing link and goes to a desktop such as say Claude Desktop and types in check the format of my sales contract and pastes the SharePoint link in the Claude Desktop as well. Your client sends the document and the prompt to a MCP server called contract analysis. The MCP server understands the sentiment of the request and goes to SharePoint and grabs the actual document or the content of the document. And SharePoint returns that back to the MCP server. Now the sampling process begins. The MCP server sends a sampling request back to the client and says, this is the content of the document, the contract. Analyze the contract for legal compliance in the US. The client sends this prompt and the content of the document to OpenAI, for example. OpenAI processes the document and returns an analysis result. Then the client returns the sampling response back to the MCP server. For example, the sampling response might include contract misses insurance clause. And then here the sampling process ends. Now MCP server has information about the contract. It goes back to SharePoint, gets the company template, and then converts your document to the company's template and makes it look nice, and then returns the response back to the client. And then the client shows the final response or result to the client, which is a formatted sales contract. And also as a response, it says your contract has an issue, which is missing insurance clause. So as you can see in this process, our MCP server managed to use the AI within the client without having AI itself. For sampling, you can use local MCP servers using STDIO or standard I/O protocol, or you can use remote MCP servers using streamable HTTP transport. You have learned how to do both of these before. If you want to run your MCP server locally using standard I/O, you have to make sure that your client supports sampling because not all clients support sampling. Let's have a look at the list of the available clients and see which one supports sampling. There is a document on the website of Model Context Protocol. I will link it to this lecture. This document shows that exactly what clients exist and what features they have. If we look at sampling, you will see that most clients do not support sampling out of the box. For example, say Claude AI doesn't support sampling, as you can see, unfortunately. ChatGPT desktop doesn't support sampling, as you can see. But some frameworks support sampling. For example, say Visual Studio GitHub Copilot supports sampling. If you want to use sampling and you see that your client doesn't support it out of the box, it's not a problem because we can code our own client. And soon I will show you how you do that. Let's go to Visual Studio and see how sampling is coded. So we are in Visual Studio. If you clone the GitHub repository of this course, you will see that under MCP there is a directory called sampling and it has a client and a server. We need to work on the client first. So in the client, what we are doing here is that we get the API key of OpenAI because I'm using OpenAI. You can change the model if you want and use your own model. And we import async OpenAI so that we can work with OpenAI. Again, if you want to change it to some other model, for example, to Claude, then you need to import the Claude client. So we have a large language model client available. In a client that supports sampling, you need a function with a specific signature to handle the sampling request. This function must have a very specific signature. I will soon explain why this signature exists. It accepts a context of type request context. All the parameters that are sent to this function are in params and their type is create message request params. The response is create message result. In this function, you get the request in params like this, and then you just call your large language model. So LLM client chat completions create, this is an OpenAI thing. You are basically sending a request to OpenAI. We use this model and the content is your prompt text. And then you get a response from OpenAI and you return it. Now in our main function, as you have seen before, we are trying to create a client and connect to a remote MCP server over a streamable HTTP transport. And you have done this before. And also you don't have to use a streamable HTTP. You can also use a standard I/O. I have used a streamable HTTP client to have complete separate client and servers so that I can explain it to you better. So the code is not any different to what we had before, except that when we create the client session, on top of passing read stream and write stream, we also need to pass sampling callback. If I hover the mouse over sampling callback, you will see that its type is sampling function type. And if I click on it, we can go to its source. You will see that this is the type. And if I click on this type, this is the definition of sampling FNT. So this class or type has this signature, as you can see. Context is request context, params is create message request params, and response type is create message result. Because you want to assign your function to this type, it must have exactly the same signature, and that is why in your client, the sampling handler function has this signature. If it's too complex and you cannot memorize it, always just copy paste from here and use it. So again, when we create the client session, on top of read stream and write stream, we need to pass our sampling handler to sampling underline callback parameter. In this example, in my server, I have a tool called generate poem, and I'm sending a topic for the poem so that MCP server generates a poem for me. Now let's go to the server. The server is very simple. It has a tool. The tool is called generate poem. It accepts a topic and then generates a poem about the topic. So whatever topic you give to me, I create a prompt that is write a short poem about and then that topic. Now, how do we do sampling? In the context, we have session, and the session has a function called create message. As soon as you say create message, the sampling process begins and we start communicating back to the client. The data that we send to the client is in the sampling message type. The role must be user and the content is text content, image content, and so forth. If it is text content, its type is text and your prompt is assigned to its text attribute. And this code, which is create message, communicates back to the client. The client receives this request in sampling handler here, sends it to LLM, and the result comes back here. And then we can do more work on the result or just return it. Let's see that, how we can run it. I run the server first, obviously. So the server is listening. If we go to the main function, you will see that I'm accepting a text or a string from the user. It says enter a topic for a poem, and then you type in a topic, and then we use that in the client and in the server. So if I go and run the client, I enter life as the topic of the poem, and you will see that I'm getting a poem. So this poem was created by OpenAI in the client, but it was returned to the server first. The server could have used this for some other purposes or even process it further and then return it back to client again. So that is how sampling works.